Hello dear friends, once again welcome. Let us now discuss about the problem in which what we have to do, we have to find out the simplest force system or to reduce the given force system to a force. Okay, so in this question what we have to do? So firstly we have to identify the number of means how our force system is subjected to, or you can say subjected to different forces and couples. Okay, then what we have to get in this question? So force system to a resultant means the resultant force. So how many forces are acting there? So we can identify here. This is the force 1, this is force 2, this is force 3. Okay, so number of forces are 3. What about the number of couples? So it is equal to, in this system we can see here there is a couple C1. So it is 1. Okay. So a system is subjected with 3 forces and a 1 couple. And now we have to get the simplest force system, or you can say reduce the given force system to a force. Okay. To a force means what? The resultant force. Okay. So it is very simple. What do we have to do? So at the last, ये आपको पता होना चाहिए, इससे बहुत आसान हो जाता है. ठीक है. So we know the principle of moment. The principle of moment. Okay. From this we can write like a CR resultant is equal to the R position vector cross product of the resultant force. Okay. So through this we can convert the whole force system into the resultant force only. There will be no couple. Okay. So through this what we get? What will be unknown? This is known. Through the calculation we will get this, we know. Okay. What is unknown? So this is the unknown. R position vector. This is unknown. Okay. And position vector आप देख सकते हैं all the forces and a couple lies in which plane? So our answer is in x y plane. ठीक है. So what will be its coordinates? So R means what? We are talking about x, y and z values 0. Okay. So here we have to get x and y. Where the resultant lies. तो सारी फोर्सेस को एंड कपल को किस फॉर्म में कन्वर्ट करेंगे हम? रिजल्टेंट के फॉर्म में कन्वर्ट करेंगे. एंड वेयर इट लाइज. ठीक है. वो कहाँ पे एग्जिस्ट करता है? ओके. कोऑर्डिनेट्स वी हैव टू फाइंड आउट. Okay. Also, we can locate the also we can locate the resultant, means the direction we can get from here. Tan theta is equal to summation of f y divided by summation of f x. Okay. So focusing on this means focusing on this the principle of moment. Now let's start how to get the resultant. Okay. So how to get the resultant? It is equal to f1 plus f2 plus f3. Okay. And what about the resultant couple? So this is the resultant couple, and there is only one couple is there, so it is equal to this. And here, and the R1 multiplied by F1 plus R2 multiplied by F2 plus R3 multiplied by F3. And these are what? R1, R2, R1, R2, and R3 are the position vectors. Position vectors of the forces, respectively. Okay. So firstly get F1. How to get F1? And it is given. From this we can write F1 here. देख सकते हैं F1, but it is inclined. Okay, so that's why F1 we will get it is inclined by 30 degree from the x-axis. Okay, so from here F1 can be represented by this. It is a vertical component of this, means this one, and the horizontal component this one. So it will be the vertical component with the negative signs, and magnitude is here 1000 and cos 30 degree. It is the I component. What about the J component? So it is a negative x direction, so that's why negative 1000 sine theta and with J. Okay, what about now F2? So F2 it is purely vertical and a vertical, so and negative direction 500 Newton. Okay, J, and it is Newton. It is also Newton. F3 is equal to F3, you can see here, it is here. So F3 is equal to 250, and with I component the unit is Newton. Okay, and one couple is there, so it is C1 bar is equal to, आप देख सकते हैं the direction is here clockwise is taken minus, and it's the moment is acting perpendicular to the x and the y. Okay, that's why K, Z axis, about the Z axis, moment is acting about the Z axis. Okay, and so direction is here, clockwise is taken here negative. Okay, so from here what we can get, the resultant force, that is equal to the F1 plus F2 bar plus F3 bar, and what we get here 1000 cos 30 degree I, then minus here 1000 sine 30 degree and J component. Okay, then plus F2, so it is with minus sign. ठीक है, so ये क्या हो जाएगा 500 J, then F3 is equal to plus 250 I. So what we get from this, we get this is equal to minus 616 I minus 1000 J. Okay, so this is our resultant R. This is our resultant R, and this is the X component, this is the Y component. Okay, what is next? So next is to get the resultant couple. Okay, so आप देख सकते हैं from here Okay, so position vectors are required. In this case, position vectors are required. So how to get that? Let us write here. R1 is what? देखिए F1 को देखिए कहाँ पर है. So here R1, this is for the perpendicular distance. Okay, so suppose this F1 is resolved in the perpendicular distance, and from A, suppose we are taking moment about A, so what will be? It's a distance. Okay, so it is this distance. Okay, perpendicular distance means from A it is 3 meter in the x direction. That's why 3I. Now coming to F2, so what will be R2 here? So R2 is 3 meter plus 3 meter. Okay, so it is 6I. What about R3? So R3 आप देख सकते हैं, it is the horizontal force. Okay, so perpendicular distance is required, means perpendicular distance means this one required. Okay, so perpendicular means y direction. So क्या हो जाएगा? 3J here. Okay, so in this way we can get the resultant couple. So let us write this C1 first. This one it is 150K, and then plus R1, and R1 is what here? R1 is 3I, and it's a cross product of F1. So F1 is what here? आप देख सकते हैं. Let me write this, and plus 6I multiplied by F2 plus 3J multiplied by F3. And by putting the expressions, or you can say the vectors of F1, F2, F3 values. Okay, so what we will get? This we will get minus 5400K. Okay, and here one can one should know the cross product, and one should also know the dot products. Okay, like I'm going to say that as you all are aware, but once again see here regarding cross product, what we get. Suppose I multiplied by I is equal to J multiplied by J is equal to K multiplied by K is equal to 0. In this is, since I multiplied by J, then it becomes K, and so on. I'm not going to repeat the things. Okay. Also, the dot product. You can see here. You can refer here. This. Okay. So, what we got? Ultimately, we got the R resultant is equal to 616I minus 1000 J, and C resultant, that is equal to the summation of moment A. This I forgot, sorry. This is equal to R1, means this is equal to what we get, minus 5400K. Okay, and then what is the next? So what is the next? So here R can be shifted, because we want this one, CR is equal to R and cross product of the resultant. Okay, so here R can be shifted to a suitable point so that it alone represents the above force couple system, and it is determined by the, this is the principle of moment. Okay, and here, so CR is equal to what? This is equal to minus 5400 and K, and R, let's say X I and Y J, and it's cross product of R, this one. So this is minus 616 I minus 1000 J. Okay, so ultimately what we get? We get here the 1000 X and plus 616 Y is equal to, if you compare the coefficients, okay, and this is what? This is, let me, so how to get this? Because it is the coefficient of J and it is a, sorry, coefficient of K. Here it is my mistake. Yeah, coefficient of K, and it is also coefficient of K. So what we get? Minus 1000 X plus 616 Y is equal to 5400. So this is the equation we get. Okay, so from this we cannot get what is our X, what is our Y, we cannot define. So for that, suppose here, now let's suppose the R lies somewhere on the x-axis. Okay, so here then we can put y is equal to 0. Means this equation now can be written as 1000 x plus 616 multiplied by 0 is equal to 5400. So from here what we get? X is equal to, we get, and one thing I'm forgetting, it will be it is a minus sign, this I forgot. Okay, so X is equal to what we get? Ultimately we get 5.4 meter. Okay, now what about the magnitude of the resultant? So it is R is equal to 616 square plus 1000 square, and it is coming from where? So from where? From here, resultant force factor. Okay, so this we get 1620 Newton. And what about theta? So theta is equal to 10 inverse, and it is, this is the x component. Okay, so 1000 divided by, sorry, this is the y component, this is the x component. Here it is x square, here it is y square. Okay, so let's take x here. So x here is what? 616. So what we get here? 58.40. So now we have converted the force system consists of forces plus couple into only the force, means the resultant force. Okay, and where it lies, where it lies, so it lies at x is equal to 5.4 meter. From where? From the point A, if you see in the figure. Okay, and what about theta? It is equal to 58.4 degree. So in this way we have solved it. Thank you. So dear friends, there may be one confusion, like how to identify the range and where the cases, okay, where the situation we simply consider the equivalent force system, or where the situation when the equivalent force system is converted into the range. Okay, so if the resultant and the couple both are orthogonal, so this is in the case of orthogonal. Okay, so if both resultant and the resultant couple CR are orthogonal. Orthogonal. Okay. Then what will be the next step? Okay. So next step will be simply according to this question, simply convert the couple, or you can say remove the couple. Better remove the couple. Okay, and have get only, you can say get only the resultant. Okay. So if you see the previous video, so in this condition, if orthogonal, both are orthogonal, resulting force and resultant couple, so no need to think about range. जब आप range की बात करेंगे तो फिर आ जाता है कि what about the resultant couple, two components like a parallel component and the perpendicular component. So here this perpendicular component C perpendicular is actually perpendicular to the resultant. Okay, not C parallel. C parallel is the parallel to the resultant R. ठीक है, so ये सब components हमें नहीं लेना है in this case. अगर both are suppose not orthogonal, in that case that can be written here. If R multiplied by CR is equal to not 0, then R resultant R and the resultant couple are not orthogonal. So reduction of force system makes a range. Okay, so in this question we don't need to worry about, we don't need to bother about, we don't need to take the range. Okay, क्योंकि both R and CR are orthogonal. तो simply क्या करना है, R का हमें the coordinates we have to find out, direction we have to find out. That's enough.